So when we are studying logic, we can take formal systems, we can take logics in general as something defined like this, as a pair composed by a set of formulas and a consequence relation. This approach indeed has been developed by Jean-Yves Beziau in the Universal Logic project. So the idea is to take logical systems as structures like this without any kind of restrictions in the consequence relation. So this F is a set. If you put here a set of propositions, a set of sentences, a set of formulas, so you define consequence relation for linguistic entities. So if you want to be like something more, develop something more general, so you need to say that this is just a regular set, not specifying the nature of this set. So in the consequence relation is regularly defined as a subset of the power set of F, Cartesian product F. So this is a very general way to think about what a logic is, and this kind of perspective is in the realm of universal logic. And of course, when you have something like a logic defined in this way, you could also say, for instance, that let's put here L to say that it's the consequence relation of this logic. This logic is a general system. I'm not saying that it's classical logic or intuitionistic logic, right? So we take now, we could say, oh, let's define the anti-logic of a given logic by a set of formulas and the consequence relation defined for this set. Then I will put here conditions to define what an anti-logic is. So we could also say that we have here something called counter logic, right? And a consequence relation for counter logic. Dealing with these other logical structures, we have approached in an article. You can find the references in the description of the video, and in an article called Logics and Their Galaxies with some collaborators, Bensusan and also Souza. And when you put something like this, you see that given a logic, you can generate many different logical structures, because of course you could put here other kind of entity. So we define logics like this. You say that you have a set of sentences, and in this logic L, you can derive phi, for instance, right? So, and we define the anti-logic of L if and only if in the anti-logic of L, you do not prove phi. Similarly, for the counter logic, you could say something like this. So if you have phi as a consequence of a set of premises in L, if and only if here you prove, let's say, the negation of phi, and this negation here depends obviously of a given logic. So you could say this is classical negation, this is discussive negation, this is intuitionistic negation. So counter logic is always defined for a precise kind of negation. So let's say this is classical negation, right? So this consequence relation is generated in the following way using this kind of strategy. But what is important here now, let's concentrate in the case of anti-logic. So here we have logics in a very general way, but let's say now that let L be classical, propositional logic, right? So L is classical propositional logic. So in this way, we have here all formulas which are logical validities in classical propositional logic. So of course, in classical logic, we have something like this. The principle of non-contradiction, right? This is the case in classical logic. You can deduce the principle of non-contradiction from any set of premises. So when you put something like this, you see here, given the consequence relation of the anti-logic, so this is the case if and only if the anti-classical propositional logic does not prove phi and not phi. And you can continue this procedure for many different kinds of formula. So this idea of generating anti-logics, this idea has been proposed by the Polish logician called Łukasiewicz. Łukasiewicz has an article on the theory of rejected propositions, and this is something very important if you take into account what logical pluralism is. When you say that we have a plurality of logics, you mean that there are many logical systems. We have classical logic, but we also have paraconsistent logics, we have intuitionistic logics, many-valued logics, and so on, right? But the point here is that when you assume these structures, like let's say anti-logic or counter-logic, you can see that there are a giant variety of logical systems. And when you are building sciences, the procedure goes like this, and then I will connect it with what I just said on universal logic and these logical structures, and especially anti-logic. When you're constructing sciences, you take, in general, the regular procedure is to take classical propositional logic, right? So you take classical propositional logic as the main basis of your investigation. Then you enrich this by some notions, you put quantifiers, things like that. Then you have first order logic, and then you have, after that, you can generate first order theories. And especially here you will say that we have ZF, Zermelo-Fraenkel set theory, right? And at the same level you have also Peano's arithmetic. And then here we can say that we have the totality of mathematics, and this is mathematics in general. So here you could put, let's say, geometry or topology or algebra, but all these areas constructed given this classical propositional logic as basis. So we have here, let's say, classical mathematics, and then sciences are here, right? And then sciences are here. So here we have physics, here we have biology, and things like that, which are theories constructed taking classical logic as a standard or a pattern of reasoning. So you can figure out now clearly that, as I said, given classical propositional logic, we can generate the anti-logic of this. So the idea is that you could put here another propositional logic, let's say the anti-classical propositional logic, and obviously as you can see here, this would give rise to anti-first order logic and to anti-set theory, anti-arithmetic, anti-Peano's arithmetic, anti-mathematics, and anti-sciences in general, right? So this shows that all our theories are based in this important fact that we are departing from classical propositional logic. But imagine, we could build a whole new hierarchy of theories taking into account anti-logic. But anti-logic is not the unique way we have to develop logical structures. We could define counter-logics, we could say super-logics, and defining different operations, right? And this would give rise to a whole new atmosphere of logical constructions. So when we say that we have mathematics in general, we are at this level, and we are talking about classical math and classical sciences. And this is very useful for us up to this level, because we are using these tools, we are able to construct sciences which are, let's say, able to provide us with some comfortable ingredients for our lives, right? So we can buy an airplane ticket, we can use airplanes, we can we can find medicaments, and we have internet, computer sciences, and things like that, which is all we have up to this level. So the point is that maybe some fragments of the universe could be formalized and understood, maybe only using other kinds of logical tools. I mean, at the departure, you should take maybe other logics to understand, let's say, other fragments of reality. And all we have up to this level is this science constructed based on classical logic. And so now it's easy to see that a lot of different theories could appear, right? And one important topic here is that when you say that you are a logical pluralist, so you say there are many logical systems, and of course there are many formulations of logical pluralism. You can say there are many logical systems, and no system is better than the other. That could be a way to see logical pluralism. And logical monism would say that there is a logic which is, let's say, the most important one, which we will use as a pattern of reasoning. And the point is that when you judge something, when you say that something is right, something is wrong, or something is valid, something is not valid, something is a logical truth, something is not a logical truth, you do this assuming a logic. So if something is a logical truth, it is with respect to a logic. This is the point. So when you have logical truth, your logical truth depends on a logic. As we saw in the anti-logic, the logic truth could be a logical falsity. So when you say that something is wrong or something is good, you are assuming a perspective. You are assuming that there is a point of view from which you can evaluate better what's going on in the other areas, right? So you are able to judge. So what I want to say is that if you want to be truly a logical pluralist, you have to suspend judgment, like Sistus Empiricus. Why? Because if you were a logical pluralist, you know that we could develop theories in many different ways, taking many different points as the departure points. We could take classical logic, but we could take whatever, anti-logics, counter-logics, and so on. So you will be clearly able to see that from the logical pluralist viewpoint, the truly logical pluralist, there is no sense to say that something is right, something is wrong, because it's always possible to construct a formal system in which a given falsity will become a truth, all right, and in which the truth will become a falsity. So what I want to let you know, and I want this to be clear, is that if you are a logical pluralist, you have to suspend judgment, because in the moment you decide to judge something, so you are assuming that there is a superior viewpoint from which you can evaluate and decide what is correct and what is not. The same kind of stuff appears also in ethics, and when you are dealing with moral values. Something which is good in one perspective is not in a different perspective. So we have to decide whether we will be logical pluralists and suspend judgment, or we will be logical monists and judge.